does it mean? And that's kind of the important thing that happens a lot with quadratics, is understanding what specific values, how specific values work with each other, is how the setups for everything else that we do will go. We're going to talk about what are called terms and then zeros. We're going to talk about, we're going to look at how you set up things with factoring, how you work with different styles of factoring, different ways to solve the quadratic problems. There are a ton of word problems for these things as well. Again, it's not anything that's horribly difficult. It's just making sure you understand how the setup works. And this chapter is also the one where it'll wind up being both of the calculator, non-calculator stuff. Because obviously there's a button on your calculator that says y equals, but that means that when we graph things, you probably won't be using the calculator. So you have to understand how to do a lot of this stuff by hand. So, especially for today, try to not use your calculator so you get an idea of how some of this stuff is going to work. So to start with, what we have with quadratics is that you guys have dealt with this before. This is, a quadratic function is one that can be written in this format. This is what you call the standard form of a quadratic. Ax squared bx plus c, where a, b, and c are the coefficients. Okay? Most of you guys are used to seeing this style, and this is the style that you guys have graphed off of before. For example, let's say that we had y equals x squared plus 5x. We'll make it even easier. Let's do plus 8. No, 6x plus 8. I'm trying to make numbers that work cleanly. You guys have all done that before. You guys knew how to factor that. You guys remember factoring? Yeah. You guys like there are many different ways of factoring. I know you guys might have learned box method, all the other stuff. I always go this one style, what times what's this, it adds to this, and I do a lot of things called, when we get to leading term coefficients. That's probably mainly next week, middle of the week. There's a bunch of different ways that I do it. That forces you to one specific style because it will always work. It takes a lot of the thought out of things. But for example, in something like this, let's go back and think about how you guys graphed to begin with. When you graphed values, you always pick stuff around the y-axis. Do you guys agree with me on that? Yeah. Remember how you made tables like -2, -1, 0, 1, and 2? We did all that kind of stuff. Well, when you're graphing quadratics, each quadratic, when they're in this format, has some similar qualities, okay? And it's very, very easy to work with if you know those qualities. Do you guys remember if it was up like a cup or down like a round? Remember hearing that before with quadratics? Okay. What's the leading term coefficient of this? It's 1. If it was 0, it wouldn't be a quadratic. It'd be linear, wouldn't it? So it's 1. Is that one value positive or negative? Positive. Since that a value is positive, this will be up like a cup. If the a value is negative, it would be down like a round. All quadratic equations will look like what we call a parabola. It's either going to be up or it's going to be down. Eventually, they're going to go left and right, but we'll do that another day. I know, it's crazy. So what we have here there are going to be some rules. Now, one of the easiest things to say is that if a is positive, the parabola would be up like a cup. Okay? If the a value is negative, it would be down like a frown. See where I'm going with that now? Okay. Now, within each parabola, they are symmetrical about each other. They're symmetrical about an invisible vertical line. There is this invisible vertical line. What is the vertical line called? Yes, sir. Not the, okay, it is the y-axis, but when you have a vertical line, what's the equation of a vertical line? Was it x equals a number or y equals a number? It's x equals a number, okay? So you're not wrong about the y-axis because it goes vertical, but every vertical line is written as x equals a number. Well, there's always some, what we call an axis of symmetry that goes through a parabola, okay? Now, in this case here, so let's see here, we've got this, draw this again. touches this spot right here. So we have, this is an A positive, so it's up like a cup. Axis of symmetry, or we just call it AOS. That is the vertical line that goes through what's called the vertex. Okay. The axis of symmetry is x equals a number through the vertex. Now the vertex of a parabola is an ordered pair. That means that this ordered pair is some value x and y, isn't it? So whatever that value of x is at the vertex, that's the x equals a number that goes for the axis of symmetry. Okay. Now the way that we can work with these things is how you find them is very simple. When you have this format of y equals ax squared plus bx plus c, this axis of symmetry is always located at the same values every single time. It's where x equals the opposite of b over 2a. That's how you figure out the axis of symmetry. It's the opposite of b over 2a. So that example that I wrote down a second ago, I think it was y equals x squared plus 6x plus 8. Yeah. So what are your a, b, and c values in this case? A is 1, b is 6, and c is 8. So if I want to figure out the axis of symmetry, that's going to be where x equals the opposite of b over 2a. Well, what's the opposite of 6? Negative 6. Be negative 6 divided by 2 times 1, which works out to be negative 3. So that means when you do these things, you can figure out where that axis of symmetry is going to be located. I'm going to put that on the smartboard here. Back to here, so y equals x squared plus 6x plus 8. A is 1, B is 6, C is 8. Our axis of symmetry is x equals the opposite of b over 2a. So we say negative 6 over 2 times 1 will give us negative 3. Now, we knew a minute ago when we look at this problem, the x squared plus 6x plus 8, is that going to be up like a cup or down like a crown? It's going to be up like a cup. The reason that's up like a cup is because that first term is positive. So whenever I'm doing these things, I do a few things first. What's A, B, and C? And what direction is it going to go? Because if I know what direction it's going to go just from looking at the problem, I know that when I start doing some substitution stuff later on, if I screw something up, I go, oh, I missed the sign. And I can fix it. Right? Because this tells me it has to be up. Now, this axis of symmetry is at negative 3, which means my vertex of this up like a cup has to have an x-coordinate of negative 3, doesn't it? So that means somewhere in here, my vertex is going to be located at negative 3, comma, something. Well, how do you think I figure out what that something is? Exactly. What's negative 3 squared? 9. All I'm doing is I'm using direct substitution into the equation. So I have negative 3 squared plus 6 times negative 3 plus 8. Oops. So we have 9 minus 18 gives you positive or negative. Negative 9. Add 8, you get negative 1. So that means my vertex is at negative 3, comma, negative 1. Ooh. What direction does this have to go? So we know it's got to move up. Now, what we do is, since all parabolas are symmetrical about that axis of symmetry, all I have to do is find a couple of points, and I would be able to have mirrored points on either side. So what I would do is, excuse me, I would just get the next ordered pair to the right or the next ordered pair to the left, and I just keep working. It does not matter which way you go. Usually one way is a little bit easier than the other. I'd say go to -2 because the numbers are smaller. What's -2 squared? So we have -2, I square it, I add to it 6 times -2, and then I add 8. So I have 4 minus 12. And add 8, you get? 0. So at -2, it's 0. Now, how far away was -2 from the axis of symmetry? 1. So that means if I go 1 the other direction from the axis of symmetry, what should my ordered pair be? -4 and 0. That's exactly right. Ordered pairs on parabolas are always equidistant from one another, from that vertical line of the axis of symmetry. Also, the axis of symmetry lies halfway between all ordered pairs, no matter how we graph these. Okay, the axis of symmetry will always be the halfway point between ordered pairs. So, do it again. Actually, what's a really easy number to work with? 5.
I think she's.
No, I don't want to do it. She thinks she's going to have a date.
Yep.
Exactly, she thinks. I'm not scary. I was handing it to you. Do you want me to just recycle it?
Yeah.
All right. So what's a really easy number that you think you could throw in here? 0. If x is 0, what's your y value? 8. If x is 0, what's your y value? 8. That's another thing to look at here, guys. When you're in what's called standard form, your c value is always your y-intercept. Your c value is always going to be your y-intercept. The other thing you'll start to notice that your x-intercepts are the zeros of the function. That's a huge thing as we start to get into these things. How do you decipher zeros via terms? How all that stuff's going to work. So I know that at 0, well, how far away was 0 from the axis of symmetry? It was 1, 2, 3 away. So that means I move it over to the left, 1, 2, 3, and up here is also at 8. So that was at what? -3, 4, 5, 6. And real quick, what's -6 plus 0? And what's half of that? Isn't that my axis of symmetry? Ooh, math is mathin'. Math is mathin'.
I like it.
And there's our parabola, if you will. Okay. What we're doing is we're using easy values to figure things through. Why? We're using easy values to figure things through. We label, actually in this case here, I forgot to make a table here, but what I would have you guys do is see how we substitute in values to figure all this stuff out. What I'm going to ask you guys to do is, obviously you're going to always label where your vertex is because you're going to tell me. So we know that this was at -3 and -1. And then after that, I just want 2 sets of what they're called are, bless you, they're called symmetric twins. Bless you. So one set of symmetric twins we had at -2 and 0. The other one was at -4 and 0. Then we got a real easy one at 0, 8, -6, and 8. So we have vertex, -3, -1, and then, like I said, 2 sets of what are called symmetric twins. Okay? Not terrible, is it? I'm pretty sure most of you guys have graphed via standard form before. Does that look somewhat familiar? Good. Let's try another one then. Okay. Same idea. It's in standard form. We have y equals 2x squared minus 8x plus 6. First thing I want you guys to do is always label A, B, and C, and then tell what direction it's going to go. I'm going to add one extra thing to it here in a second. So what's my value of A? 2. What's my value of B? Good, I'm glad you said -8. 2, -8, and C is 6. Is this one going to be up like a cup or down like a frown?
Up like a cup.
Up like a cup. So, one more thing to put into here with this up like a cup business is, if I go back to our graph here a second ago, the graph we had here a second ago, notice how it's moving as it moves, decreasing, it hits this point, and then it goes up. That's the lowest value it can be. There's nothing lower than that value. We would call that a minimum. Okay? If it was flipped around, what do you think it would be called? Maximum. So whenever you are up like a cup, your vertex is the minimum. When you are down like a frown, your vertex is the maximum. So as we go back into this, now that you guys have labeled your A, B, and C, you drew that it's going to be up like a cup. What I want you to do here is write in here, min. Because sometimes you're going to be asked, is it a maximum, or what's the maximum or minimum value? The maximum or minimum value will occur at the vertex. Depending upon type of problem, it could mean what's the maximum height something reaches. We do that with some of the word problems as we go through, so I'm just trying to get you guys accustomed to the lingo of some of these things. All right? So next, after we've done all that labeling, we go to their axis of symmetry, our AOS, if you will, which is always x equals the opposite of b over 2a. So what's the opposite of -8? 8. Okay? So we have it at 8 divided by 2 times 2, and we get 4. So we get, you're right, 2 times 2 is 4, but, so that means that my x coordinate or my vertex is at 2. Okay. So we know how to start. So my vertex is going to be 2 comma something. Well, how do we figure out the something? We substitute in. Okay. So back up here, what's 2 squared? What's 4 times 2? 8. All right. What's 8 minus 16? -8. Add 6 and you get -2. Very good. So my vertex will occur at -2 comma -2. I know it's a minimum, so I'm going to label it because we just said it was. Now, picking numbers for symmetric twins. Really easy one probably here is going to be 1 and then 0. Okay? So when we go to pick out our symmetric twins, remember we start making our table here, our x's and y's. We know the vertex is at 2, -2. So I'm going to use 1. What's 1 squared? What's 1 times 2? 2. What's 2 minus 8? -6. -6 plus 6 is 0. So at 1, it's 0, which means, what's the other value? It has to be 0. At 3, remember, your twins, always, your ordered pairs, are always symmetrical about that x equals a line. Bless you. Since 1 is 1 away from 2, 3 is also 1 away from 2, so this has to be the symmetric twin. Okay? So our ordered pairs are at 1, 0, 3, 0. And then the other one that's going to be silly easy to find is going to be, which one? It's 0. At 0, what's the y value? 6. Remember, your y-intercept will always, 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 always be the c value. Okay? So at 6, so it's at 0, 6, and what's the other value going to be? 6. At 4, good. because this is, oops, move that down. Since this is 2 away, this has to be 2 away, and there's our parabola. Not very complicated. It can just be tedious. Okay? Does that make sense? All right. Hey, who do we appreciate? Don't think I didn't hear that. I wasn't talking to you. Just guilty. All right. Does this ring a bell? Yeah. So, since we have a few minutes, I know we're not going to get to all 3 formats here. There's another format as well. This is what we call vertex form. Vertex form is just another way that you'll see quadratics written. In this case, it's written out as a junk squared. You guys remember junk squared? Binomial squared. Junk times junk. Okay, well, I have a lot of algebra going on here, so you'll be fine. All right. So in vertex form, you get these H's and K's, our horizontal and vertical. Stop it. Which means our vertex is going to lie at H and K. If your vertex is at HK, where's your axis of symmetry? Where? At H. Your axis of symmetry is going to be at H. Your AOS is going to be at X equals H. Take a wild and crazy guess. Take a wild and crazy guess what that A value is going to tell you. Up or down, right. The A value is going to tell you whether or not it's up or down. So just like it was earlier, positive A, up like a cup, which means this is a minimum. A negative A, down like a frown, which means this is a maximum. Now, how do you decipher how things are plotted out of here? Well, when you have an example, when I show you one, it all falls into place real quick. Okay. For example, let's say we have y equals 3x minus 2 quantity squared minus 4. Since this is not in standard form, this is written in vertex form, the 3 things I'm going to label off of this now are just my A, H, and K. So from just that information, you're going to be able to get everything. What's your A value? 3. Is it up like a cup or down like a frown? All right, so it's 3, so it's up like a cup, which makes our vertex a minimum. What's your H and K? It's 2, negative 4. It's 2, negative 4. The H values, if it was just x plus 2, it would have had to been x minus a negative 2 for the H value. So the H is 2. The K value, since it's plus K, that means it's whatever the value is. In this case here, it's negative 4, so our K value is negative 4. Yes, ma'am. Yes, because if it was written like x plus 3 quantity squared, that means that H was negative 3. Because it would be minus a negative, that's why we write plus. It's very similar to when we did point slope form. How you filled in point slope form when you had the order correct. It's followed the same rules in any color. Okay. So where's your vertex? 2, negative 4. Where's your axis of symmetry? At x equals 2. So this idea of vertex form is actually very, very, very easy to plot off of, because you've got all the info right there. You don't have to worry about doing the half of B, or sorry, opposite of B over 2A or anything like that. You're just setting it up straight off of that. All right.
Yep.
How do you get the rest of the graph? I'm glad you asked. So in this case here, we know that our ordered pair for our vertex would be at 2, -4. Our axis of symmetry is at 2. What number is really, really easy to pick next? 1. So if I use 1, what's 1 minus 2? It's -1. What's -1 squared? 1. What's 1 times 3?
3.
What's 3 minus 4?
-1.
So at our symmetric twins would be at 1, -1. And then since this is 1 away, it has to be there. We do the same thing there, just plug and chug. And then the real easy one here would be at 0. So if I choose 0, zero minus 2 is -2. -2 squared is 4. 4 times 3 is 12. Subtract 4 and you get 8. Yes, ma'am. Different forms. What fun is that? So this was 2 away, so that would be at 4 and 8. Connect my dots. La 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 la. Okay? Let me give you a couple of these to try out for tonight. I want you guys to make sure you label everything. I don't know. We still have more to do. We're gonna hold another style. Yeah, probably.
What?
So I gave you 3 of each style, whole whopping 6. Okay? Gave you 3 of each style. The PDF file for 5.1 is on the calendar. I wasn't sure if we were going to have time to get through all 3 forms. Tomorrow we'll do the what are called intercept form. That one is, again, it's really easy to do, but it's probably one of the most important forms. Yes, sir. Yes, sir. Yeah, it's one of the problems are in that 5.1 section when on the PDF file. All right. And we'll go from there. There you are. Were you all done something, or did you want to send us Make it easy. Pick the ones next to
Everything's running up more.
Stop it.
Everybody's head. See you tomorrow.